Okay. Yep. All right. Welcome to the COSE working group meeting. We're going to get started right away because we have a full agenda. Note the note well, as you do in all working groups and as you did when registering. So make sure that you sign in to the on-site tool, or failing that, scan the QR code. But we will be using the on-site tool for queue management. So if you want to speak, raise your hand, just as the people that are remote will do. There's a set of standard resources for this meeting. Now to the first COSE specific content. We can't really go any further until we have a note taker, or even better, a team of willing volunteers to do so. Oh, Hannes. Boy, you just came off of a buff. You're a workhorse, man. Thank you. And I will note that anyone can help Hannes in real time to get it right. And you have some editorial control over the transcript if you help. So there's an incentive. So Eva and I prepared a few slides of status just from the chairs about work that's happening. For starters, the COSE CWT claims and headers draft is at the RFC editor and is currently stalled there, but for a good reason. It has a normative dependence on the COSE type header parameter. Per some discussions we had at IETF 118, which is finished with IETF last call and is scheduled for an IESG telechat in about 3 weeks. At that point, assuming things go well, it will join its friend in the RFC editor queue. They'll both get edited together and published together. So that's all a good news story. COSE key thumbprint, the chair has requested publication, which we should have done earlier, but we did it a week or so ago. Our area director, Paul, asked me to update the Shepherd review to reflect the status of some comments that had come in. I did that. That is in IETF last call right now. So there's still opportunities for you or any IETF member to say things about the draft through April 2nd as part of the IETF last call. There's the draft on timestamp token header parameter. And rather than doing a presentation, the authors asked us to just say things in the chair slides. They had asked to the list in November, should we have 1 or 2 header parameters reflecting sort of pre or post time stamping, or pre or post signature time stamping? They didn't get an answer. They made a judgment call that they are different header parameters. That's published. About 3 weeks ago, reviews are requested, but I believe that was the last outstanding question. Unless there's more discussion, we probably take that to working group last call. But again, have a look. Of the type header parameter, let me go back to the type header parameter will be on the IESG telechat on April 4th, with Ori Steele being a recusing area director by that point. welcome, Maury. Thank you for your service, as they say. So at that point, um, those two drafts, the CWT claims and headers and the type header parameters, should progress through the RFC editor queue as what they call a cluster, meaning they move together. So we have a full agenda. We have a full agenda in part because we took 2 hours of content and we compressed it into an hour and a half. Ivo and I asked for this session to be moved from Monday when it would have been a conflict with the CFRG. And we got a 90-minute slot rather than 2. So I'm going to be brutal with the time. And with that, unless there's any agenda bashing or questions for the chairs, I'm going to move right on to the first presentation, which is COSE HPKE.
Okay. Yeah, that's, as you know, this is work with Ori, Daisuke, Lawrence, and many of you from the working group. A lot of discussions. Next slide. Try to keep it short. Illustrate you where we are roughly. Here's again. So we have specifically. So there's this work happening in the COSE working group with the COSE HPKE, the counterpart. And there we made a couple of changes, which we tried to reflect here as well. Instead of the 1 layer, 2 layer sort of description, which is not very, sort of not a good terminology. We now use the direct encryption versus key encryption approach. Which indicates like direct encryption is if you only have 1 layer, which means you can only use 1 recipient, and the other one you can use 1 or multiple recipients with a key wrapping method. Okay. So nothing changed in that respect. Content-wise, terminology changed. Yeah, I think you know all of this, why we do this. So skip over that for the benefit of time. So the status, that's where it gets a little bit complicated. So the main issue is we have made a couple of sort of.
Wait, and I'm going to take an interrupt. Is somebody scribing because he was our scribe? Ivo, thank you.
Yeah. So we made some changes to the header parameters to get them also in line with the HOSI work. But the most important issue that you can also see discussed on the mailing list, and we had a lot of private mails as well, is the question about how do we bind the encryption to the context, which is something, if you haven't paid attention to this whole topic, if you use any of those mechanisms, you need to make sure that the context is the endpoints, the application you're using this for, the algorithms, etc. They need to be bound either to the key derivation or to what you are protecting the whole thing. And the story gets more complicated because we use HPKE, which has specific ways to incorporate those parameters, so you don't have full freedom. We don't want to make it too complicated because COSE specification has a context infrastructure which is pretty elaborate, but unfortunately not that super friendly to use. The attacks are complicated, but do exist. So, for example, the unknown key share attack, or reflection attacks and so on. And there's some more recent attack that was presented at the LAMPS meeting of the Prague IETF meeting, where there was a downgrade from AES GCM to AES CBC, which we suddenly have to take into account as well. So none of us is a cryptographer, although we obviously work in the security field, but cryptographer and security people are still a difference. So we've been debating many of those aspects, and I think we have a better picture now, and some ideas on what we would what we want to do, which we haven't yet fully incorporated into the document, or at least not in a submitted one. There is a PR that exists that was an outcome of the hackathon last weekend, which you can look at the working group repository. Not going through the details, it takes longer to understand. And on top of that, we've reached out to a real cryptographer, Paul van Oorschot, who said that he would be looking at this and providing us feedback within the next 2 weeks. He was the one who actually originally worked on that, or came up with this attack, the unknown key share attack with Whitfield Diffie and Wiener. So presumably he knows best what he was doing there. So I'm quite thankful for that. And so I'm positive that we will sort this out fairly soon and finally get this to completion. And then obviously the resolution will be applicable to both documents, the COSE working group and the COSE working group. We've been working on code. Here you see the header changed, EK, to avoid confusion with another header parameter on the COSE side. And yeah, those examples are still outdated, so we are going to update those as well. So there's a little bit of change there, but yeah. So one specific change that I maybe highlight is we want to explicitly indicate in the protected header on what the context actually is, because that's another, I think, another trap we could fall into, specifically developers, is to make that the context implicit, because then both communication endpoints somehow need to know precisely what that context is, because, and if you don't get it right, then the result is it will just fail and nobody knows what went wrong. I think that would be a very unfortunate developer experience. The downside of that approach is that we need to carry more bytes along. If we carry, for example, the sender, the party U, party V context, or endpoint string specifically, separately in the message.
Hannes, do you want to take questions now or at the end?
There's Mike is going to ask a question.
Mike Ounsworth. So you mentioned the recent attack lamps in Prague. Were you at CFRG yesterday?
No, I wasn't. Another recent attack?
So there's an even more recent one. Deirdre Connolly presented. So back up. I assume you're doing this to get MLChem ultimately.
No.
No. Okay. So you should still take a look at Deirdre Connolly's talk from CFRG yesterday, in that when you put MLChem into this, when you replace Diffie-Hellman with MLChem, you don't get the same properties that you expect unless you do some additional tweaking. So there was discussion of a 9180 BIS. You should just be aware of all that.
I think definitely I will do that. Thanks. Good to be aware of that. Luckily, or not luckily, there's what HBKey provides us is the hybrid version, but I don't think, or maybe that's impacted too. I don't know. Tiro.
Just to respond to Mike, right? I went through the draft that she had proposed, and there is a problem with the binding properties that Diffie-Hellman has versus MLChem has. So the other drafts are going to incorporate the changes that she's suggesting. We don't have to do any changes to this because this is pure traditional algorithm.
Yeah, but will it? So like it shouldn't impact the baseline HBKE version. It could potentially impact the hybrid, right?
It won't impact the hybrid. It will impact the pure PQChem algorithm.
The PQChem. Okay, that's fine.
Ori?
So whatever it impacts, it'll impact the chem ID that goes in the HPKE registry until we have a chem ID for whatever chem has this problem. Won't be relevant to this draft.
Yeah.
I was just going to note there is time to clarify this for exactly the reason that Ori noted. The specific thing is what will happen is you'll think you're getting the properties of Kyber and you actually don't. It doesn't behave exactly right.
Okay.
And so it should be, So it is something worth just reviewing and incorporating. You won't require much change there.
I think it's maybe another document. The other document that will be present it later. In any case, we'll have to update the code as well. We have a multiple implementations and we keep changing things. So we obviously keep updating the code, but that's what it is. We've updated the code so many times already. So it's okay. Next one. Okay, yeah. Maybe the first line sounds a little bit frustrating, but we obviously had lots of debates and like the relationship between discussion time and text in the document was disproportionate. Another complication, unfortunately, is that in COSE, also in COSE, we have also algorithms that are not AAD ciphers used for some special use cases, but there's obviously this is obviously something we have to take into account in the description and the design, and so that's something we need to do as well. And yeah, so yeah, I hope so. Our hope, I hope I'm correct here as well, is that by the next IETF meeting we are done with all of this and can finally ship this. This document has been around for a little while,
Right.
longer than expected.
And I do commend the efforts to align this work with the JOSE work. This was talked about yesterday as well in the JOSE working group. To the extent that developers that are building both are unsurprised by differences, that's a good thing. You are 8 minutes ahead of time. If people want to say anything else about this, you can add yourself to the queue. Otherwise, we have 2 more of Hannes upcoming.
Okay, then
Let's
keep going.
get on with it. COSE key thumbprint. Confirm your selection.
Okay, this is actually, you covered this during the chair update already. So it is one slide anyway. So basically what you said, we already got feedback. It's later in the stage already. There's IESG feedback or IETF last call. And so we got feedback already, which we need to incorporate. And the call ends April 2nd. So there will of course be more feedback and yeah,
Yeah, get your feedback in by April Fool's Day. Anything else?
I don't like these trips. Given the HPKE experience, I'm not.
All right. Let's move on to Hannes version 3.
Given my prior experience with SPICE, I want to get these presentations behind me as quickly as possible.
You're having a traumatized speaker, so just be kind.
I probably have to start therapy afterwards. I actually should ask IETF whether they can sort of pay me some psychotherapy. So this is the header. This is the chains of CBOR web tokens, and as a background, we had this work originally was in one of the suite software update for Internet of Things devices working groups. It was in the trust domains document. The idea was that have a way. So normally you attach a CWD and it has a key. You use the key and provide those 2 payloads. You kind of like think of the CWD with the key as a certificate, and you use that key to, for example, sign something. And you also attach this CWD, but there was no mechanism to attach a chain of CWDs like you would attach a chain of certificates, right? You often want to have a hierarchy. You don't want to have just sort of you want to have a deeper hierarchy rather than just the CA kind of, and then the end entity certificate, if you compare that with the PKI infrastructure. So this document adds that feature, and we thought that this would, why put this into, well, we thought that the suit document a specific suit document would not be the right place to describe this. And so we extracted it from there and put it into a separate document so it can be used beyond the suit environment, which I think is the right way to approach this, because some of you may also have some use cases where you actually want to have a chain of CWDs. Of course, as when you have a chain, you need to describe, at least to a certain extent, what that means, what the validation of an entity certificate, given a chain, what that actually means. So there's a little bit of the RFC 5280, the BKICS RFC that we had to sort of absorb here in this document alongside the terminology. But of course, we didn't want to go all the way to basically replicate, because for most of the, or for the use cases we have, and hopefully you too, you don't need all that PKI stuff. You don't need all this X509 stuff. You want to be minimalistic. That's the whole purpose of why we came up with these CWDs in the first place. Okay, probably said more or less everything. So there's one document already, RFC 9360, which describes header parameters that reference X509 certificates, and also header parameters that carry the certificates themselves. So passing these X509 certificates either by value or by reference. So that's what this RFC does. What this document does is it basically defines similar header parameters, but just for CWDs instead of X509 certificates. And as I explained, suit here. So, and obviously this is only useful for CWDs that have this confirmation claim, which adds this key, this key public key functionality, which would then turn it conceptually into a certificate, just in a different encoding. Okay. And here are the ones that basically, obviously I changed the name of the parameters. So like CWD back is obviously unordered, chain is ordered list, D is the identifies the end entity CWD by hash value, and the CWDU provides the ability to identify a CWD or chain by URI. Okay, Carsten.
Carsten Bormann. So we have these sets of 4 things: backchains, thumbprint, and URI in so many places now.
Okay.
And I'm just wondering, is there a useful way to generalize this? I mean, do we have to have 4 header parameters for X509 and 4 header parameters for C509 and another 4 header parameters for
VCs?
So is there maybe something that can be extracted that is common between them? Of course, you also have these extras down there, which are different.
Of course, it would be possible to do that, for example, by tagging some of the structures, I could imagine. In an ideal world, if we start again, we would probably somewhere indicate what the type is of the credential, and then we just say bag or sort of like chain or etc. That may be a more useful approach, but now, given that we have these other things already, it's kind of a little late. We missed the point of no return, I guess. Well, maybe there is a way that I don't see right now.
So I just wanted to get the thought processes starting here, because I think this is the 3rd one, and we will certainly get more. And so, I mean, these are all signed statements. And
there's definitely a pattern here. And obviously, like, I exploited that pattern by literally just doing a find replace. So if something comes to your mind, let us know.
So I'm going to take off my chair hat for a minute and speak as one of the designated experts for registering these things. The contents of these are big. So it's not like we need to burn 1 byte header parameter values for these. If they were 2 byte header parameters, or even 3 byte, which I'm not advocating, then we're in a space that we're not going to run out of anytime soon. So as long as you're not asking for a 1 byte value, if it makes programmers' lives easier, I'm fine with the multiplicity of header parameters. Okay, chair hat back on.
Okay. Yeah, makes sense. Yeah. Yeah, and definitely not small, neither the X549 nor the CWD is small up in a relative way, but still not small. Yeah.
Yep.
And chains, of course, neither. Okay. Yeah, I think slides speak for themselves. Tobias.
Yeah, I was just going to sort of say, I think I support this as an idea. I definitely see the use cases for it, and I think to your point, Hannes, because we've already kind of proceeded with a certain design direction with how X509 certificates are embedded, that consistency with that is probably what developers would maybe value more than starting a new pattern. And the other thing I would say is that often these thumbprint, bag, chain, it's usually one of them is used. So even though there might be lots of registrations in a registry, an implementation may only be using one or maybe two at a time. It picks from the list. So it's not like they're all present in the header of a CWT at the same time, a lot of the time anyway, that I've seen.
Yeah, that's actually a very good point. I need to check the original document and this document to what it says in the case when you actually have all of those parameters in there. What is the semantics of it? I'm not so sure about that, but maybe something to clarify. Yeah. Ori?
Yeah. It'd be a big problem if you had all of those in a message.
Yeah, I don't.
And it also be a sort of a problem if you have CWT claims and headers and ISS and KID and like other combinations of key discovery components could have interactions with these that leading developers to hit their head on their desk a lot. So
yeah,
we at Skit, just for context, we spent a lot of time debating X5T and X5C like chains and which one should be required, which one should be optional, and if you have them, what should you do with a KID value? Yeah. Should KID be present? Should it not be? What about ISS? So I don't.
That's a good one.
I would be. Yeah. I would actually, if I were you, I would like try not to talk about that in your document, but then you may end up actually kind of needing to in consideration section maybe at some point.
It's maybe actually a topic for the COSE guidance document because we already have some of those out there. For each individual document was fine by itself, but the fact that we kept piling onto it made it more complicated. And just in the earlier talk, we were speaking about the BART-EU, BART-DB for identifying endpoints, yet another different parameter. And that makes it, in the end, quite complicated or confusing maybe. So we should talk about the potential attack scenarios there, or at least developer confusion. So in any case, so what I'm asking the group is to adopt this document. I think it's also in a state where it's a good starting point, quite reasonable. It's minimalistic. I tried to be minimalistic. Ellery asked on whether I want to have some key usage parameters defined, which I didn't want. But of course, it's up to the group to decide this ultimately. But I wanted to keep it as simple as possible. That was the goal of the write-up. Basically a replica of what was in the suit document.
Are people in the room largely in favor of holding a call for adoption?
see.
Is there anyone who wants to speak against that? Okay, Ivo, I think you and I will run a call for adoption on the list. Thank you. And we are 10 minutes ahead of time. John Bradley, you are next.
So I'm going to do big hand gestures to represent Giuseppe, who couldn't be here. So Giuseppe and I have been working on this. Well, honestly, mostly Giuseppe, but who may or may not be up to watch this from Italy. So we can move on to the. So this follows on the previous Hannes's previous presentment about chains. So I'm chaining off of his to present the notion that we can represent OpenID Federation trust chains in CWT headers. There are, so essentially this presentation boils down to, I have some polite things on the slides, but the reality is that X509 sucks. It doesn't represent many of the things that we actually need for Federation information. So being able to, rather than refer to the Federation metadata by reference, we want to include it by value, because so a given entity who receives the CWT may have access to the trust root, but they may not be able to actually walk the trust chain of the Federation information. And you can probably skip, yeah, that slide. So the idea is that, oops, how come that has a different slide than that? Oh, no, it doesn't. Okay. The notion is that in Connect Federation, we have a rich information about trust marks and other things that you couldn't easily represent in an X509 certificate. Yes, you could put absolutely anything in an X509 certificate and nothing will understand it or parse it. But this is a way of bringing together COSE and Connect Federation metadata. There are use cases for this potentially around wallets, etc. It's a relatively short document. There's one header parameter. Yes, the things that are included in that header parameter are a chain of JWTs, which is what I can see in the eye of the person coming up to speak. But I'm happy to discuss that. It's not like I didn't anticipate it. But the reason why it's JWTs is that currently Connect Federation is a JWT format. So you could lobby the authors here to have an alternative COSE representation of those JWTs, which would probably upset Brian deeply. But so I'm going to call for adoption so that you can rip it apart in the working group.
Mike Prorock.
Mike Perrock here. Could there perhaps be a little bit more of a generic structure that says, yes, this could be a JWS embedded and identified in such a way, but we could also maybe set ourselves up to go reference things that are like CWT or CWT like bags, and giving ourselves a path into these other chains and stuff that are going on. It just felt very odd to me when I get down there, and I knew where it was coming. I knew when it was going to show up, and it's like, and then B string JWS, and I'm like, yeah. So that's all.
You have to do the hand movement.
Yeah, I wonder, like I'm thinking, I always have a déjà vu, thinking of what Carsten asked a few minutes ago, whether we could have something more generic, because it sounds to me like you are describing the JWD version of what I just described as a CWD.
Yes, that's why I said I was chaining off your president.
Now,
Okay.
now I get that hint.
Okay. If you explain a joke 3 times.
And the chairs did put these next to each other on purpose.
And now I'm suggesting something not obvious. Maybe we should work together to just define something generic that works for CWD and JWD. It won't say OID, OpenID Federation, but because the content is,
as long as we can profile it to do what we want for OpenID Federation, I don't think there's a problem with that. No. So yes, assuming that if the working group wants us to work together so that we can have a common thing. Mike?
I would be highly supportive of a collaborative effort working towards a common goal that unifies things,
You
as
have to
opposed
bigger,
to trying, as
bigger.
opposed to trying to split things up and nitpick over details. I think we could find a way maybe to allow for profiling like this and link it up with other things. That would be great.
Brendan?
I'd just say I'm supportive of that effort as well. The only thing that I would mention on that is that it's critically important that this doesn't blow up to large sizes or complex parsing. The original target, the reason that we started the previous work, was a very simple delegation technique.
So I have to admit that Connect Federation trust chains could be large.
It's for me, it's not about whether it can be large, it's more that it can be small.
Right. So ideally we would, do this by reference, but you can't always do things by reference. So other questions?
Okay, Ivo, if you concur, it sounds like the sets of authors should talk to each other and make a recommendation to the working group.
We could talk to each other.
So,
Ori?
Ori Steele, I do suggest that you talk to each other, but I also suggest that you talk to the folks in STIR who are developing a similar sort of chaining mechanism in JWT land for telephony applications. And I think if you talk to them, you may find that you have yet another friend who's doing a similar type of activity. So I'm happy to connect you offline.
Kirsten.
Carsten Bormann, is this just a chain of JOTs?
Yes.
JWS, excuse me. Or do you have to know it's actually OIDC JWS?
You would have to know that, well, like anything, you have to understand the trust model, and you'd have to know how to parse the OpenID Connect Federation metadata.
Yeah, so there are 2 layers.
Right.
One is the syntactic
Right.
layer. This is a chain of JWS. And then there is the semantic layer that says, oh, you have to interpret this OIDC like. Because we are not providing this semantic layer with X509 chains or C509 chains or the ones Hannes talked about. Maybe we have to.
Well,
yeah.
If you want to convey something more complicated than this key is signed by that key, which is signed by that key, then yes, you have to know how to parse it. Not all X509 certificates are created equally. A browser's implementation of parsing X509 will not deal with, say, the federal PKI bridge, just to pick on someone. I mean, you know.
Yeah, that was not my question. My question was not, do I get to parse this, but after having parsed this, do I know what it means?
Well, that's.
No, that's not the same thing.
So simply knowing that it's a chain of X509 certificates doesn't guarantee that you understand all of the extensions that might be required for the particular application.
Right.
Yes.
So it would be good if by the time you do this, you know what application it's for.
Yes.
And this is the case here.
Yes.
Good.
Any other questions?
So I guess my takeaway is we will have to specifically find out whether there's some application-specific semantics in there that requires a certain validation logic, or whether there is a possibility, or asked differently, is there a generic sort of part to the whole story or not? If there is a way to generalize, then
well, we may have to have a structure that holds JWSs, CWSs, etc., and then separately indicate what the application logic to understand those collections of things. So we may have to look at parsing it out, but I think that the application needs to know what kind of application logic it needs to understand, the trust information that's in that chain of objects, however they happen to be encoded.
Okay, thank you, Giuseppe.
Grazie.
Mr. Prorock, post-quantum.
You will notice that there are now two things on the title slide, just dilithium and Sphinx Plus, which really aren't the names anymore.
Are we in San Francisco?
No, I didn't update that either. So let's go to the next slide. We're going to quick rip through this. I think this is old news for the first couple slides, but they're there. So let's go to the next slide. And let's just mention that there's a strike through on Falcon. Obviously, if the working group says, yep, let's go kick this up and go do it, we'll do it. But right now, not seeing a huge demand since we know we're starting with two other things. Yeah, exactly. So if at some point there is, we can come back and revisit it. Got a good path there. Next slide. Next slide. This is the big stuff. Got some draft updates. So we got some renaming. This is thanks to NIST. So we have MLDSA, SLHDSA. These are the things we're familiar with. Thanks to Ori, we actually finally moved this stuff over into the COSE working group GitHub off of, I think, my personal or work one. I don't remember which one. But the key stuff is now that that stuff's been fully specified, we can go through and rip a bunch of stuff out. So we were able to drop a whole bunch of text. Great. This makes life easier and easier to implement and understand. Next slide. The big help one, it asks, test vectors, implementation tests, all that kind of fun stuff. I think a bunch of us are working on that, but always want more eyes. The other thing is waiting for any weird parameter set adjustments, finalizations. It could still happen. So we should be aware of that. I think I have one more slide if I remember correctly, which is this. The security considerations. We had some really good ones in. We're going to go back, revisit those, and just double check that they all still apply and make sure there aren't any new ones lurking since some parameterization adjustments were made. Importantly, there's some stuff around like padding and stuff like that that's going on in terms of implementations. And we've already seen some quirky things pop out, one of which was brought up earlier related to Kyber. where the NIST version might have some slight differences because of some of those design decisions that were made as things came over that introduced unintended consequences. And so we should just make sure we get good eyes on that and account for those in the security considerations. So we'll do that between now and the next IETF. Those will go out and they'll be ready for review. So we will share those with the list when that update goes out in 04 or 03 or whatever we're up to. So that's where we're at. One question I do have, and this is really for the group and probably for the chairs, which is at what point should we go ahead now that we kind of know the base, you know, at least for dilithium, I think it's very clear that there's going to be 3 kind of unique AL combo type deal parameter set identifications. At what point can we register that stuff so we can actually test that stuff consistently across implementation? Sphinx, we could probably either look at the full set or otherwise, but I think I think we're at a point where that side is stable enough, and we need to be able to start testing some of these things against each other. And welcome feedback.
Chair hat off. Mike speaking. I will say that the pre-registration procedures at this point are flexible enough that with chair approval, things can be done that make sense. There has to be some statement of expectation of stability, but pre-registrations are there exactly to help facilitate early interoperation testing and whatnot. So we can have that conversation.
Thank you, Mr. Chair, hat off.
Carson, are you still in queue? Are you still in queue? No.
Okay. Mike.
Mike Ainsworth. Both speaking as author of one of the parallel lamps drafts and also speaking as Russ Housley, don't register IANA anything until NIST is done tweaking stuff. That's how you get incompatible. Yeah.
The do you think we're going to see different matrix sizes with dilithium, out of curiosity?
That I don't know, but I mean, what you don't want is incompatible test vectors.
100%, yeah. So that's one of the reasons I was asking the group at large, because like if we think we're there, cool. I know we'll probably discuss this in the next PQIP meeting too, right? But I do think there will be some changes. But can we clearly identify enough to test on consistently? That's the big question. So. Oh no! This would be pre-reg. Yeah.
So as I said, I was distracted, but we have several ways in COSE to have
private, yeah,
private
big numbers,
or obviously non-final things. So maybe we can use one of them.
That might be a good path. I think one of the things we're looking at is some of these tests that are going across multiple parties that might not necessarily want to get in the same room with each other, and where you can just say, hey, go point at this.
Yeah, indeed, there is a private use range. Yeah. And it would be fine to grab some beautiful numbers out of the private use range and put them in the draft.
Excellent. That might be a good approach. So that's awesome feedback. Thank you, Mr. Karsten and Mr. Jones. With that, I cede any time that remains, if any.
Thank you. Next, we have Ori. COSE receipts.
Ah, yes. So I think I'll actually adjust this for once. All right, much better. This is the COSE receipts draft. It's called COSE receipts now. It was previously called COSE Merkle Tree Proofs. It had even a longer title. And the short name was Cometer, which I did like that name. However, COSE receipts is really a much better name for several reasons. Like primary reason being that this isn't limited to Merkle trees. It's a generic scheme for creating receipts for logs that have different proof properties. And so we're going to get into the changes that have been made. I think these changes are made since the last IETF and a little bit before the last IETF. And I unfortunately did not present this draft and updates to the last one. So you're kind of getting 2 IETFs worth of updates in one set of slides, and hopefully that's good. Karsten, you're still in the queue, but okay, I'll ignore. Let's go. All right. So what is this COSE receipt stuff? Well, you know, I think the way to think about it is it's a kind of counter signature. It's not just, you know, I looked at your signature and I'm giving you a normal COSE counter signature. It's I looked at your COSE envelope and I'm giving you a kind of counter signature. And that kind of counter signature that I'm giving you also says that I have a proof of inclusion or a proof of consistency or other kinds of proofs that go along with that. And that's an interesting addition to, you know, counter signatures, because it's kind of proving, you know, 2 things: the counter signature part, and then there's this other proof stuff that rides along with it that can be independently verified. And what's cool about that is that in a simple sort of cool and possibly dangerous, so love your feedback on this part, you can get a kind of interoperability just by verifying the counter signature piece. So if you speak ES256 or EDDSA, ED25519 or MLDSA or whatever, and you're verifying the receipt, you can just verify the receipt and you can say, I trust the signer of this receipt, I'm good. There's another kind of verification where you can say, I trust the signer of this receipt, I verified their signature, and I verified their inclusion proof, which proves that this message was in a log, a transparency log, certificate transparency, key transparency, or SCIT, supply chain artifact transparency. And then there's an even deeper verification where you can do all of what I just said and then verify the signature on the original message that went into the log. So that would be like, a use case for that would be like a signed binary that then went into a transparency log where you verify the inclusion in the log and then you verify the receipt that was signed by the transparency service operator. Next slide. So I kind of got into why to do it already. SCIT needed it. That was the first reason. It's also a kind of, we're in COSE. It's a generic building block. It's meant to be useful for anyone who has this need to provide a kind of enhanced counter signature that can support these other data structures. And there are, you know, applications outside of just like the direct transparency log use cases, depending on the nature of the data structure that you're including your messages in. But you know, supply chain transparency and key transparency are kind of the obvious ones. And certificate transparency is the original system that this particular draft is sort of aligning to as an initialization of the concept. Next slide. So we're up to 04 now. We've been working group adopted for some time. The main changes in 04 are kind of adjusting the framing and to really de-emphasize the Merkle tree parts. A lot of people were kind of really getting attached to not liking Merkle trees or liking them or just talking about them like a lot. And really, this is about the envelope structure. It's about, you have this verifiable data structure or a transparency log, and you're including information in it. Yes, lots of systems use Merkle trees to represent that structure, but you can use this for other cryptographic schemes like cryptographic accumulators or other set membership inclusion proofs, or potentially even fancier mathematics if you can imagine it. And the draft creates kind of general purpose structure that lets you sort of register your verifiable data structure and the proof types it supports. And then those can go into your receipt, and your receipt can get whatever powers come from that data structure or cryptographic scheme. And I think, you know, the other main change in this version is we were kind of thinking about how to manage these code points and registry integration points for this. So we have kind of 2 things we need to do. We need to say, what verifiable data structure is this receipt for? So is it for a binary Merkle tree with SHA-256? Is it for a binary Merkle tree with SHA-512? Is it for a cryptographic accumulator with some other hash function? So we have to identify the verifiable data structure, and then we have to have a way of including the proof types that that data structure supports. So a binary Merkle tree with SHA-256 can support the inclusion proof and a consistency proof. And so I should be able to take those and I should be able to pass them along in my receipt so that I can verify those proof types. And so what we did was we copied the COSE key and COSE key parameters registry approach. And for those not familiar, it's kind of a two-layer registry. First, you register your key type, and then you register your parameters that go with that key type. And what's nice about that is it keeps your registry consumption on the parameters really low, because every time you ask for a new key type, you kind of reset the counter and you go back to counting from -1 to -2, assigning points. Not so nice thing about that is that you kind of have to think about two parameters to make sense of the object as a whole. So I think this is a good structure for what we need to do here, but if you read the document and you have comments, love to hear from you on the list. Next slide. So some examples. Here you can see this tag 394 in the unprotected header, indicating that this COSE sign 1 tag 18 has multiple receipts, potentially multiple receipts. This is just showing one. And you can see that it's a B string sort of here. The entire receipt itself is going to be decoded in the next couple examples. But I want to call out this tag 394 issue because right now SCIT is requesting the registration of this, and I think that's incorrect. I think that COSE receipt should be requesting the registration of this header parameter, since then everything regarding COSE receipts is in one place. And since this header parameter is not specific to SCIT's use case, it's just basically a generic header parameter. You need to use this structure.
I think someone taller than me was at the microphone. Mike Perrock here. Definitely, I do not think SCIT architecture should be registering 394 unless there is some specific semantics item. And I think we dealt with that just a little bit ago with the OpenID items and things like that, right? So when we're looking at the generic structure, if this is the primary generic structure and it's the primary generic structure that's going to get utilized by SCIT, which I believe it is, operating in that group a bit and doing some code around that, I think it should be registered by the draft that defines what a receipt is. So.
Procedurally, who can liaison with SCIT and have that conversation productively?
I can.
Okay, thank you.
There's at least 2 other SCIT people here, so we could delegate to one of them. So I'm neutral. You want? do you want that? All right. It's leftover. Looks like the SCIT people are going to let us do it. Okay. So this is the receipt. So actually, could you go back one slide? Just to, yeah. It's confusing because these are nested and they're encoded. So I want to call out the blue thing here. We're about to look at just the blue thing. All right. Moving forward. This whole structure is the blue thing, but we're going to look at the specific subcomponents of this structure to understand the anatomy of the receipt. So the first part here that's interesting is the unprotected header has this proofs property with -222, and that's a map that has a -1 in it, which is indicating an inclusion proof. And then inside of that is this specific encoded inclusion proof. Now, the thing I was saying before, like, how do you know that this -1 is an inclusion proof? That's that 2-layer registry structure that I was talking about before. So, and you can see this decoded protected header here. It says -111:1. That's the verifiable data structure parameter that tells you this is a receipt for a verifiable data structure that is the SHA-256 binary Merkle tree defined in RFC 9162. And that's what tells you that -1 means inclusion proof from RFC 9162. So, and just to be clear, the decoded protected header at the bottom, that's the decoded protected header of the receipt that we're looking at the top. So together, these tell you this is a receipt. It's a receipt for an inclusion proof. It contains an inclusion proof. And this would help you prove that a given message was in a transparency log. That message could be a key, it could be a software artifact, it could be a certificate, but this is the generic structure that tells you how to do that in COSE. Next slide. Right, so I was hoping this document would be basically ready for working group last call, and as I went through the document, there's a part of it that I still don't really feel comfortable with, and it's this consistency proof design. So in the document, we are initializing these registries for the verifiable data structures and for the proof types. And there's really only one entry that we're initializing them with. It's the RFC 9162 SHA-256 binary Merkle tree and the inclusion proof and consistency proof registrations for that structure. And we spent a lot of time on the inclusion proof, so I feel like it's pretty good. And Skip people will probably be mad if we changed it, but it's our document, we can change it. So inclusion proof, I feel good about, but if you read the document and you hate it, let us know. The consistency proof one, I just feel like it never got any real review in Skit since they don't use inconsistency proofs for anything. So there wasn't any argument about that structure ever there. So I don't think the consistency proof has gotten anywhere near enough review to call that part done. And we need to finish both of these in the document and frame them well in order for this to sort of establish the registry and conventions for this particular draft and call it good. And so I think this is kind of blocking us potentially, although it's the main remaining design piece. So I don't know how you all feel about progressing and addressing that part. And then the other two parts are the early allocation question for header parameters, like you maybe don't want to see -222 and -111 in examples, the next IETF. Maybe those could be early allocation, and same thing with the tag 394. And maybe it's a good time to request director reviews from IoTDir and Skit and maybe some other, well, not Skit, but like good to request early director reviews to start to focus the attention on the consistency proof piece, or just generally get better comments. I'd like to get the document to working group last call before the next one, next IETF.
Are there people either in the room or participating remotely who would be willing to volunteer to provide reviews? And in particular, if you could review the consistency text,
Yeah.
that would be super helpful. Who feels like they have enough subject matter expertise to provide useful reviews? Okay, Monty is volunteer number one.
With a disclaimer, you said subject matter expert. And my disclaimer is I'm not a subject
Okay,
matter expert.
fair.
On Merkle trees. I will be happy to look at the document.
And
I will ping some folks.
You want the architecture, Skit architecture to move through? This is going to block it
Yeah,
eventually.
that's my motivation.
This is going to go into a cluster with the Skit architecture eventually. So because Skit architecture takes a normative dependency on it.
okay. Any other feedback? You on?
Quick comment, maybe. Yeah, more of a question. The reference in the document is to certificate transparency. Is that a generic definition of a Merkle tree that's being reused by Skit?
Yeah. So a RFC 9162 defines the minimal binary Merkle tree with the smallest consistency proofs for that kind of data structure, assuming that the text in the RFC is correct. It also defines a bunch of other stuff, which we're not using any of that. We're just using the inclusion and consistency proofs from RFC 9162, and we're packing them into this COSE structure. And then we're signing them with a COSE sign one, like a That's the only parts that we're using from RFC 9162.
Okay, so my ask is to be very clear in the IANA registry on what exactly is being registered. If this is the ultimate VDS, fine. If this is one specific use case that we know of today, let's say so, and leave the space open for other.
It's just one, and so that we're initializing the registries we're requesting with this one. But the idea is like we're going to see Merkle mountain ranges and other verifiable data structures requested for registration under a specification required policy. And that's what the current requirements are. And there's some guidance to the designated experts to try and make sure that anything that goes into that registry is hitting a really high bar, because you don't want a situation where there's lots of these different systems that are, you don't want all the same normal registry issues apply. Like you don't want duplicates or things that are almost similar or that have basically the same security properties. So we kind of want the experts to be really hostile to anything that might happen.
All right, thank you, Ori. John Mattson.
Thank you. So this is CBOR encoded X509 or C509. Next slide. So we have closed quite many issues in the last two releases. Gotten a lot of comments from Liyun Liu on Brian's side posts. Thanks for that. Current version is relatively stable. All the revocation related topics have been moved out to a separate draft, like revocation list and OCSP. And the plan is to ship this as soon as possible. We have also released updated source code under a free BSD. It's coded in Rust. It's X509 to C509. Update of the old code fixes all the known issues and add the features updating to the latest draft. We're now working on the reverse direction. Will be hopefully be released in a couple of months. So next slide. The main remaining issue is the location of the signature algorithm. There has been discussion in the GitHub and no real conclusion. We would like to have the group's help to solve this, either here, but maybe more realistic on the list. So basically in X509, there is two places for the signature. C509 shows one of these, but now we got a comment that this, when you want to parse, this creates unnecessary complex parsing. You need to parse down in the structure to find the signature algorithm and then parse back up. So there's a change request to change the place on the signature algorithm, and there's been heavy resistance to that change because people have implemented and deployed this, so they don't want any changes. So the potential discussion is make the change, optimize the processing, don't make the change, just keep things as is, or to basically define new certificate types. So you keep 0 and 1 for like draft version of the specification, and then you register new for the final.
Mike Perak, just want to comment, if we're going to make a breaking change, now is probably better than later, or if we must do double certificate type. But if we're, I mean, the whole part of why we're moving this stuff, or looking at this stuff in COSE and CWT, is to optimize processing, etc. Let's make that change now. I know it's frustrating to people, but it's a dash whatever. It's not done yet. Right?
Yeah.
Mike Ellsworth, I have not read the draft. Are you proposing to only have it outside the signed data?
No, it should still be signed.
It is still protected.
Yeah, it should still be signed. I don't remember exactly what the proposal was to, but the proposal is to not change. It's signed currently, and it should still be signed.
Right, because that's the reason there's two in X509 is
yeah,
you have one signed. And
at
one
least my
unsigned.
strong opinion is that it should keep to be signed. I will make sure it is. Yes.
Carsten Moorman, those people who have already deployed this, how will they like a solution where we essentially disallow types 0 and 1 and only have types 2 and 3?
Yeah, I guess they would be. I guess they might be okay. I don't know what has been discussed really disallowed and so on, but I guess 0 and 1 would be here like it's some pre-standard version which we don't recommend. It's not the final RFC, but that would have to be.
Yeah, Carsten. To your question, registering.
Too loud.
You're very loud.
How do I change that?
That's very quiet.
No, we don't hear you at all.
Now somewhere between, please.
Yeah.
You're muted.
Is this good enough?
This is way too loud.
Is this good enough?
This is better.
Okay, so I'll try to whisper very carefully. So what I'm trying to say is just that the person opposing this change was fine with defining new code points, new certificate types, but we didn't explicitly speak about recommendation around dating. So I can't really say, but that's the feedback we got. So it was fine with defining, for example, code point 2 and 3 for the new format. That's it.
Can anybody translate this? So I know what he has said.
The transcription on screen isn't bad. That said, you have 3 minutes and you have another 5 slides.
Is this better?
What would you like to do?
I don't
Can
know.
you
I
hear me
think
now?
if we have any more comments on this issue, we
No.
discuss this issue. Otherwise, I go quickly through the slides and we have to. It doesn't seem to be more comments, so then we go quickly through the slides. Next. So we have added pen. We have now 3 ways to encode things: int, oid, and pen. Next. We have, as agreed, we have updated the way how to signal between certificate request and certificate, native and non-native. Next. We have defined, as requested, we have defined structures for private keys. You can see them here. They're quite simple. The exact format of the subject private key is still to do. Next. We have registered media type, content format, and we are using the content format to define file format according to this magic number RFC. Next. We finally added examples of dev ID certificate. Next. And yeah, next step is to encode the reverse direction and publish that also under a free BSD license. It will also be done in Rust. I think we're quite stable. Hope to finish quite soon. More reviews, very welcome. We hope to be ready for working group last call later. I think we need to continue discussing this topic about moving this signature. Hopefully now people are up to date on the issue.
So Mike, speaking as an individual, I mean, it's always the case when doing data structure design that the preference is not to duplicate information, because if you duplicate it, then you have a new error condition which you've self-created, which is what if they're not duplicates?
We only have one now, and we are not planning to take back two. It's just moving the place where the signature algorithm is.
Oh, okay. As long as you keep one.
Yes.
That's
we will keep
much
only
more
one.
constrained decision. Thank you.
We will keep one, and it will be signed. The only question is where in the structure.
And what is the reason for potentially moving it?
To optimize processing, so you don't have to dig down to find the signature algorithm. Yeah. The complaint that it's not optimal to process is valid. Yeah.
Okay. People are encouraged to give feedback on that. Thank you, John. Tobias, you are up next.
Thanks, Mike. Can you hear me?
We can. Maybe talk a little quieter.
Okay. Thanks. So this is just a quick update on a previously adopted draft. Next slide, please. So developments since the last IETF meeting is we've changed to use the EC key type for JOSE and the equivalent EC2 for COSE, because we are using uncompressed key representations, and we've changed the identifier spelling to represent and reflect the fact that the algorithm and its origin, the curve and its underlying origins is representative of people's initials. Next slide. We currently only define uncompressed key representations, and that is because there is no suitable stable reference to a compressed representation. There is one defined in expired draft at the CFRG for pairing-friendly curves. However, the compressed representation is bespoke to these curves, so it doesn't follow, say, SEC1, where there is a predefined kind of standardized format of metadata for indicating compression and the sign of the Y-curve. It instead sort of uses a variation of SEC1 that is that takes up the 3 additional bits remaining on a byte boundary for the curve, and so that is originated from a Zcash implementation, and because that is not standardized, we have moved to an uncompressed key representation to remove our dependency on this draft. It does leave the question, though, for this group: do we want to also define a compressed key representation, and if so, how would we go about that? Next slide. I think that's pretty much it, actually. And discussion.
Hello, Ori Steele. Don't do the compressed curve representation in this draft, but now I'd like to talk a bit about what it might look like in another draft. Like, it's basically the same thing that we see for the P curves in terms of compressed representation. So the Y piece is going to become false or whatever, and then compression is going to go into X, and then on the other end, someone's going to always decompress that to put it into whatever format they need that supports the expanded format before they use it. And like I know it sucks that the original versions of these keys were done this way, but like, in my opinion, the compressed keys are like mostly not helpful. And in the Go COSE library, like, we're probably not even going to support them at the interface boundary. So like, I don't know. Maybe someone says like, I really like compressed keys. Like, that's my favorite thing. Definitely go do it. I think do it in another document. That's it.
Thanks, Ori. And that's it. Short update, really, on the draft.
All right. Thank you, Tobias. Finally, Tiru.
Good afternoon, everyone. I presented this draft yesterday in the Joseph working group, and I got several feedback. I don't plan to go through all the slides, so I'll work on the feedback. Next slide. Yeah, Shor's algorithm is going to break existing traditional asymmetric crypto. Next slide. Yeah, ML Kyber is one of the finalists and potentially will be standardized in another couple of months. Next slide. Then skip this slide. Yeah, I think this is the one that's of interest. I believe that we already have a COSE HPKE, which is already being going through, I think, finalized in this working group. We recently published an hybrid screen draft, which is basically talking about a combination of traditional cryptographic algorithm plus PQChem. That's typically referred as hybrid schemes. And then the eventual path is to use pure PQChem. There are several reasons to do that. One is that it's already being advertised as a CNSA 2.0 standard. MLChem has been around for more than 7 years, and once cryptographically relevant computers arrive, then we eventually have to deprecate traditional algorithms. So, but what I realized after publishing this draft and then the feedback I got from the working group is I was in the WIMSI working group, I couldn't attend CFRG, but MLChem doesn't seem to have the same security properties as what HPKE does because of the way the key derivation binds the ciphertext and the public keys the way HPKE does, whereas MLChem currently does not bind the ciphertext. And that to get the same binding properties, there's a new HPKE MLChem being proposed in the CFRG. So I eventually plan to update this draft to align and make sure that we have the similar security bindings that HPKE has, and we will publish a revised draft. I think I'll stop here because rest of the slides needs to be changed based on that feedback.
Next.
That's it. Yeah.
Oh, you're done?
Yeah, I mean, since the feedback I already received, there's no point in going over that. But if there's anything new feedback, I would like to hear.
All right, Ori Steele. I'll give an abridged version of the same feedback I gave in HOSE. You know, for COSE, we have algorithms. We have a lot of them. We could go about adding these chem algorithms as sort of first-class entries in the registry for cases where we previously had, you know, ECDH algorithms. There's a lot of ECDH algorithms in the COSE registry now, and there's about to be like a bunch of HPKE algorithms that are going to fit in there as well. So the same sort of comments that I gave in the HOSE working group. Does the COSE working group want these chem constructions like just the native chem construction without the HPKE wrapper and the HPKE wrappers? And there could be maybe because of the unique, concise and IoT deployment considerations for COSE, perhaps there's a reason to come to a different conclusion than HOSE on that point. But my general sense is like, let's not have a bunch of algorithms that are doing mostly the same thing. So that's basically what I said in HOSE, repeating it for this audience.
Yeah, makes sense. Thanks.
Does anyone else who's following this space closely like to add any thoughts? I know there's a number of you in the room. Yeah. Mike Prorock says off mic, we got a lot of this yesterday, but he appreciates the work.
Thanks.
All right. Thank you, T-Row. Is there anything else people would like to say generically about or to the working group? Otherwise, we are right on time. Ivo, would you like to say anything?
Yes, so on the chat, we were discussing whether we can get a quick vote for the C509 draft, basically which way they would be going. I don't know if anyone can summarize this better, but yes. So, well, basically, I guess the question is whether we, I don't know, if John wants to, we can get the slides of John and get a poll, but yes, whether we want to have the new, more efficient way, the only the the presented way. Yes, thank you. Governor.
Can you hear me in some reasonable loud sense now?
Yes.
Okay. So
yes, that's better.
Thank you. So the proposal that was discussed was to move in the chat. Mike Onsworth kindly included the format of the certificate, and the proposal was to move the issuer signature algorithm, which is currently at the end of TBS certificate, to the top of the structure. So you don't have to parse twice before you know the signature algorithm. So that was the proposal, and then there was a discussion in the mailing list whether we should make that change at this stage or not. So essentially, let's say it's instead of the last entry would be like second or third entry in the that doesn't matter, but it's before all the bulk content. That was the request by the person making the proposal. Is that clear, the proposal?
Yeah, I just put a straw poll that says vote yes if you want to move the location of the algorithm.
Now the question is about issuer signature algorithm in response to the chat here.
John, go ahead.
Yeah, this seems quite clear that we want to do this optimization. Then the question is, should we align new numbers? I guess that was not in the current question to still support all the implementations. I think we have many numbers. That's not the problem. Problem would be if we feel that it split the deployments.
Clarification question: is there already pre-allocation of assigned numbers for this draft?
No, there's not.
All right. Well, if I were Jim Schad, which I'm not, I would be saying, until it's final, it's not final. I wouldn't suggest, well, as Jim would say, all the requested assignments in the COSE registries are TBD until they're actually assigned. So it's up to you what you want to request as numbers, and you can change your request, but they're not final until they're allocated.
Could I comment on that? Yeah. Sorry.
Yeah, my recommendation would be to just change the numbers, only register the new ones, and maybe mark the old ones as reserved.
Okay, Karsten, I believe you just had the last word, unless, Jörn, are you still in the queue?
Yeah. So could we ask that same question to the working group?
Okay. Our limited response seems to support Karsten's suggestion. Thank you all for an engaging and hopefully useful session to each of you. Enjoy the rest of your week. Thank you.
Sorry.
Oh, Ivo, go ahead.
Mike, could I ask one more thing?
Go ahead. Go.
So we are almost resolved this issue. We're signing new numbers, but we also had the question if we should, like Karsten proposed, reserve the old numbers, or if we should recommend. I mean, we can just take that simple question: should we reserve the old numbers so that people will only use the new numbers for new deployments? Or was that implicit in your question? I mean, you only asked, should we change the numbers?
And again, I'm not going to run the poll because we're over time. But
Yeah, I think it's too many. I think there is no objection to Karsten's suggestion. Let's do that.
Go ahead.
Yeah, if you want to take that question to the list, you can feel free. But I think you have actionable outcomes. So
okay,
thank you all.
Thank you. Thank you all.
Okay.
Thank you.
Thank you, Eva. Good morning.
This way, it's like a hack twist and everything. It's all set to go.